Ever imagine, like, controlling the brain with magnets? Sounds kind of sci-fi, right?
It does.
But that's exactly what we're looking at today.
Yeah.
We've got this MIT News article all about a potential breakthrough in brain treatment.
Right.
Tiny magnetic discs that could change everything.
It really is pretty revolutionary. We're talking about moving away from like invasive brain surgery
Oh, wow.
and towards much more precise and non-invasive treatments.
Okay, so let's break this down.
Yeah.
Our mission today is to figure out how these tiny discs actually work,
Mm-hmm.
what makes them so groundbreaking,
Right.
and what this could all mean for the future of brain treatments.
Well, to start, I think it helps to understand like the current situation.
Okay.
Deep brain stimulation, or DBS,
DBS.
is a pretty common treatment for conditions
Yeah.
like Parkinson's disease
Right.
and obsessive compulsive disorder.
Mm-hmm.
But DBS involves implanting electrodes
Okay.
directly into the brain.
Yeah, I can imagine that's not a simple procedure at all.
It is a major surgery.
So this research that we're talking about today is offering a way
Yeah.
to achieve similar results, but without needing to go through surgery.
Exactly. Think of it this way. Imagine trying to fix
Okay.
a tiny circuit on a motherboard,
Mm-hmm.
but you're using like a really clumsy tool.
Right.
You're more likely to do more harm than good.
Right, of course.
So precise brain stimulation is crucial
Yeah.
because different regions of the brain are responsible for different functions.
So these nanodiscs that we're talking about offer a more precise way to stimulate the brain.
Yeah, they're incredibly small.
The article mentions they're incredible small.
We're talking 250 nanometers across,
Wow.
which is about 1/1500th of the width of a human hair.
I'm having trouble even picturing that.
Yeah.
Injecting something that tiny into the brain.
And they're injected directly into the brain.
Okay, how do these nanodiscs actually work?
So each disc has a magnetic core and a piezoelectric shell.
Okay.
Imagine the nanodisc like a tiny drum
Okay, a tiny drum.
and a magnetic field applied outside the body.
Uh-huh.
It hits that core like a drumstick,
Okay.
making it vibrate.
All right.
And this vibration strains the piezoelectric shell,
Yeah.
generating an electrical pulse,
Mm-hmm.
which then stimulates nearby neurons.
So you can think of piezoelectricity,
Right.
like those push-button lighters.
Exactly.
Apply pressure, get a spark.
Yeah.
I got it.
Simple.
So essentially, we're using magnets to remotely control
Yes.
these tiny generators within the brain, and all of this without requiring any genetic modification.
Right.
That's pretty amazing.
It is.
So have they tested this in anything living yet?
They have. They successfully stimulated neurons
Okay.
in a dish,
Right.
and they even targeted specific brain regions
Wow.
in living mice.
And living mice.
Yeah. So they targeted the ventral tegmental area,
Okay.
which is associated with reward,
Mm-hmm.
and they also targeted the subthalamic nucleus,
Okay.
which is kind of like the brain's motor control hub. And they even observed behavioral effects.
Interesting.
When they stimulated only one side of a mouse's brain,
What happened?
it would start rotating.
What?
Yeah,
That's incredible.
it is.
So these nanodiscs can actually influence behavior
Yes.
just by modulating neural activity in these specific brain regions.
Exactly.
This is really cool.
It's exciting stuff.
This could change how we treat neurological conditions like,
And it goes beyond just treating existing conditions
really?
by precisely targeting different areas of the brain.
Okay.
We can also learn more about how it works,
Yeah.
potentially leading to new discoveries.
In other fields too.
Oh, yeah.
That's fascinating.
Mm-hmm.
So this technology has the potential to not just treat conditions,
Right.
but also advance our understanding of the brain itself.
Absolutely. But
Yeah.
we should keep in mind, this research is still early.
Of course. But it's hard not to get excited about the possibilities.
It is.
Imagine treating something like Parkinson's
Yeah.
with a simple injection and magnet.
It's pretty remarkable.
It almost feels too good to be true.
Well, it is incredibly exciting.
Yeah.
And because these nanodiscs are so small,
Right.
they could be much safer
Okay.
and better tolerated by the body
Uh-huh.
than traditional implants.
Yeah.
And the researchers were actually able to achieve levels of neuronal stimulation comparable to those conventional implanted electrodes,
Right.
but with a significantly reduced foreign body response.
So less invasive, potentially safer, and incredibly precise.
Yes.
What's not to love?
Well, we still have a lot to learn.
Of course.
We need more research to fully understand the long-term effects of these nanodiscs on the brain.
Right. Safety is paramount, especially when we're talking about something as complex as the brain.
Absolutely.
Yeah.
But the initial findings are very promising.
Okay.
And the potential benefits are enormous.
Like what?
Well, imagine a world
Okay.
where conditions like epilepsy, chronic pain, and even Alzheimer's disease could be treated with this technology.
Wow, those are some serious conditions.
They are.
It sounds like the applications for this technology could be much broader than we initially anticipated.
One of those exciting aspects is the potential for targeted drug delivery to the brain.
Oh, yeah, the article did touch on that briefly.
Yeah.
So instead of just stimulating neurons, we could use these nanodiscs to deliver medications directly to specific brain regions.
Precisely.
This could revolutionize how we treat a whole range of conditions.
It really could.
Wow, I'm already picturing all the possibilities. This is truly groundbreaking stuff.
It is a testament to the ingenuity and creativity of these researchers.
Okay, so we've covered how these nanodiscs work, their potential benefits, and even hinted at some of the broader applications like targeted drug delivery.
Right.
But let's dive a little deeper into the specific conditions that this technology could treat.
Okay.
We've mentioned Parkinson's, Alzheimer's, epilepsy. Where should we start?
Let's start with Parkinson's disease. Remember those mouse experiments where they targeted the subthalamic nucleus, the brain's motor control hub?
Yeah, and the mice started rotating when they were stimulated?
Exactly. And that same region is often targeted with those implanted electrodes for DBS in Parkinson's patients.
Okay.
So the fact that they were able to induce those motor responses with these tiny nanodiscs is a really promising sign.
You know, I was reading about a patient who had DBS surgery for Parkinson's.
Okay.
And the recovery was rough.
Yeah.
If this nanodisc technology works, it could be life-changing for so many people.
Absolutely.
Just an injection and then using magnets to control the symptoms. It almost sounds too good to be true.
It's still early. But the potential is there.
Yeah.
And Parkinson's is just one example.
Okay, what else?
Think about epilepsy.
Epilepsy? How could this help with seizures?
Well, seizures are essentially caused by bursts of abnormal electrical activity in the brain.
Right.
And remember, these nanodiscs can generate those precise electrical pulses.
Yeah.
So theoretically, we could use them to disrupt those abnormal signals and prevent the seizures.
So instead of a patient needing to take daily medication, we could control their seizures with this non-invasive technology.
That's the idea. And it's not just about stopping the bad signals.
Oh, okay.
It's also about promoting the good ones.
Interesting.
Think about chronic pain.
Chronic pain. So many people suffer from that.
Yeah.
How does this tie in?
Chronic pain is often the result of misfiring nerves, sending those constant pain signals to the brain.
Right.
So with these nanodiscs, we could potentially stimulate specific nerves to block those pain signals.
Gotcha.
Or even modulate the brain's perception of pain.
Wow. So people could live pain-free.
Yeah.
Without needing strong medications or invasive procedures.
Exactly.
This is like science fiction.
It really does feel futuristic.
What about Alzheimer's?
Alzheimer's is a bit more complex.
Okay.
But there's definitely potential there.
I know there's still so much that we don't understand about Alzheimer's.
That's right. But one of the hallmarks of Alzheimer's is the buildup of amyloid plaques in the brain, which disrupts communication between those neurons.
Oh.
Now, some research suggests that brain stimulation might be able to clear those plaques.
Really?
Or at least slow their formation.
So we could use these nanodiscs to target those plaques.
Potentially, yeah.
And slow the progression of Alzheimer's.
It's a possibility worth exploring.
Yeah.
And remember that targeted drug delivery aspect we talked about.
Right.
That could play a huge role here.
With Alzheimer's.
Yes, imagine being able to deliver those medications directly to those plaques.
Right.
Really maximizing their effectiveness while minimizing any side effects.
That would be a game changer.
It would.
It really sounds like these nanodiscs could revolutionize how we treat so many neurological conditions.
Absolutely.
But is it really that simple?
Well,
are there any potential downsides or challenges that we need to consider?
Of course.
Yeah.
even with all of this potential,
Yeah.
we have to remember the brain is incredibly complex.
Right.
There's always a risk of unintended consequences.
Of course.
Especially when we're talking about manipulating that neural activity.
So while the possibilities are really exciting, we need to be cautious.
Right.
Make sure that this is thoroughly researched and tested.
Absolutely.
Before widespread use.
But I think it's important to balance that caution with a sense of optimism.
Right.
This research is a significant step forward in our quest to really understand and treat the brain.
It's amazing to think that magnets could potentially hold the key to treating these complex neurological disorders.
It is remarkable.
And the fact that this is non-invasive, it could be more accessible to patients.
Right.
Fewer risks, faster recovery time.
Absolutely.
Compared to brain surgery.
So we've talked a lot about the potential benefits.
We have.
But let's shift gears for a moment.
Okay.
And talk about the future.
All right. The future of this technology.
That's next for these tiny but mighty nanodiscs.
So we've talked about all these conditions this could help with, but what about the technology itself? Like, what are the next steps here?
Well, there are a couple of areas where researchers are focusing.
Okay.
First, they're working on improving that magnetoelectric conversion.
Okay.
Basically, making those nanodiscs even more responsive to the magnetic fields.
So fine-tuning those tiny generators we talked about?
Exactly. To make them even more effective.
Makes sense. Anything else?
Yeah. They're also exploring different materials and designs for the nanodiscs to enhance the precision and effectiveness of that stimulation.
So a more custom approach to treating different conditions, like personalized medicine for the brain.
I like that.
And, we briefly touched on that targeted drug delivery. Is that something they're actively researching too?
Oh, absolutely. That possibility is a huge area of interest.
Okay.
Think about it. Imagine delivering medications directly to those brain regions, minimizing those side effects, and really maximizing those benefits.
Now that's exciting. This whole deep dive has been incredible.
It has been.
We went from these tiny magnetic discs to potentially revolutionizing brain treatments. And it all started with just one article.
I know.
About research at MIT.
Yeah.
Sometimes those most groundbreaking discoveries come from these really small things.
It is remarkable what these researchers have accomplished.
Yeah.
And I think it's really just the beginning.
Really?
Think about all the possibilities that are still out there. This technology could change how we treat neurological conditions.
Right.
But also really deepen our understanding of the brain itself.
It makes you wonder what else is out there.
I know.
What other breakthroughs are waiting to be discovered?
I think we'll be hearing a lot more about these nanodiscs in the coming years.
For sure. And for our listeners, we want to leave you with something to think about.
As this technology develops, it's important to think about the wider implications.
Okay.
How will this affect our understanding of ourselves? What ethical considerations do we need to address?
It's a lot to consider. Well, that's our deep dive into the world of these tiny magnetic discs.
It has been.
And their potential to change brain treatments. It's been a wild ride.
It has.
Exploring the cutting edge of science and thinking about the implications of this mind-blowing technology.
Until next time, keep those brains buzzing.